Okay, so imagine this. What if we could use your medical history to, get a glimpse into your future health? Like having a crystal ball, but for healthcare? Well, that's kind of what we're diving into today. We're talking about AI and how it's being used to unlock these amazing insights from, get this, mountains of data locked away in electronic health records.
Yeah, it's really incredible when you think about it. Using AI, especially this thing called deep learning, to actually find those hidden patterns and make sense of it all. But you got to realize EHRs, they weren't exactly designed with this in mind.
So it's not just a simple matter of feeding the data to an algorithm and getting answers.
Oh, definitely not. It's way more complicated than that. Think of EHRs like a giant library, but instead of being perfectly organized, the books are kind of just stacked wherever, notes scribbled everywhere, information all over the place.
Librarian's worst nightmare.
Sorry.
But for AI, maybe it's like a gold mine.
Yeah, you could say that. And that's where the research we're looking at today comes in. We're talking about the work of Yogesh Kumar. His doctoral thesis really dives into how to make deep learning work with this messy EHR data.
So he's figuring out how to organize that chaotic library, so to speak, so the AI can actually find the good stuff.
Exactly. And he's getting some really impressive results. I was reading one of his papers, and get this, they used Finnish healthcare records to actually predict how often people would end up seeing a doctor in the following year.
Wait, so they could actually predict how many times someone would visit the doctor. Was it accurate?
Surprisingly, yeah. They even compared it to some other prediction models, the simpler ones, and the deep learning model, well, it consistently came out on top.
Wow. So it's not just theoretical. It actually works. But what's the point? What can you do with that information?
Oh man, the possibilities are huge. Think about it. If you could identify individuals who are at a higher risk of needing more healthcare resources, maybe you could intervene early. Potentially, you could prevent some of those health issues down the road, or at least be way more prepared to handle them.
So we're talking about moving away from just reacting to health problems and toward a more personalized, proactive approach to healthcare.
Exactly. And speaking of personalized, that's another really cool thing Kumar's research gets into. It's this concept called transfer learning. Have you ever heard of that?
I'm not sure, actually.
Okay, so imagine you're training an AI, right? But instead of starting from scratch, you could actually use a model that's already been trained on a massive amount of general medical knowledge. It's like giving the AI a head start.
So it's like instead of having to learn the alphabet, it already knows how to read.
That's a great way to put it. And then you can take that same AI and fine-tune it on a smaller, more specialized data set. Let's say you want to predict healthcare needs for people with diabetes. You could take that AI that's already got this broad medical knowledge and then focus its learning on diabetes specifically.
So it's like taking a med student who aced their basic science classes and then having them specialize in endocrinology or something.
Yeah, exactly. And Kumar's research has shown that this approach, this transfer learning, can be really powerful when it comes to predicting healthcare needs for folks with certain diseases, even when you don't have a ton of data to work with. They tested this with type 2 diabetes, bipolar disorder, even multiple sclerosis, which is pretty amazing when you think about it.
And with multiple sclerosis, wasn't that one of the conditions where they didn't have a ton of data to work with?
Yeah, exactly. But even with those limitations, the AI could still make some pretty decent predictions. It's like, imagine a doctor, right? Even if they haven't treated a ton of patients with a specific condition, they can still draw on their broader medical knowledge to make informed decisions. And that's kind of what's happening here with this transfer learning approach.
So it's like giving the AI a foundation to build on, which is crucial when you're dealing with something as complex as MS.
Absolutely. But to really understand how Kumar got these results, we kind of have to dig a bit deeper into the weeds here. Like I mentioned earlier, EHR data, it's messy, right? So we got to unpack why that is and how he tackled it.
Yeah, let's do it. So what makes it so difficult for traditional deep learning methods to handle this kind of data?
Well, the thing is, EHRs, they weren't really designed with AI in mind. Their main purpose was to document patient care, which means they're full of inconsistencies. Doctors using different abbreviations, nurses might use slightly different terms for the same thing, plus the way they even record information can change over time.
It's like trying to read a book where every chapter was written by a different author with their own style and handwriting.
Yeah, that's a good way to put it. It's a recipe for confusion, especially for an AI trying to find those patterns and make sense of it all.
So how do you even begin to solve that? How do you get the AI to understand this, medical jargon?
Well, Kumar had to come up with some pretty ingenious solutions. One of the things he focused on was the timing between a patient's visits.
Oh, interesting. So, like, someone who sees their doctor every few weeks is painting a different picture of their health than someone who goes once a year.
Exactly. That kind of temporal information, the when and the how often, it gets often overlooked in traditional data analysis. But for understanding how a disease progresses and what someone's future needs might be, well, it's essential. It's like reading between the lines of a patient's visit history.
It's like those gaps between the visits, they tell a story too, right?
Yeah, absolutely. And that's where deep learning really shines, I think, because these models, they can pick up on those subtle patterns, those interactions in the data that humans might miss. Like, it can connect the dots in ways that we just can't.
It's like having a detective who can analyze a crime scene and notice things that nobody else sees. Except, in this case, our detective is an AI with algorithms instead of a magnifying glass.
Exactly. And to create this super sleuth AI, Kumar, he used some really interesting tools. One of them is called multi-headed attention. Have you ever heard of it?
Multi-headed attention. It sounds kind of intense.
It does sound kind of intimidating, right? But the idea, it's actually pretty simple. Imagine you're like trying to predict someone's health future. So you're looking at their entire medical history. You wouldn't give equal weight to every single detail, would you?
No way. You'd focus on the big stuff, right? Like
Yeah.
major diagnoses, chronic conditions, things like that.
Right. And that's basically what multi-headed attention allows the AI to do. It learns to prioritize, it focuses on the most important parts of the data, and ignores the rest.
So instead of getting hung up on like a case of the sniffles from 5 years ago, it's honing in on the fact that someone has a family history of heart disease or that they've been, gradually gaining weight over time.
Exactly. It's like having a whole team of specialists, each one highlighting a different but important part of a patient's history. And by combining all those perspectives, well, the AI gets a much more complete picture of that person's health.
That makes a lot of sense, especially with how complex our health can be.
Yeah.
But you mentioned earlier that these AI models, they often need a ton of data to be trained effectively, right? What happens when you're dealing with a rarer condition where you just don't have that much data to work with?
Right, and that's where transfer learning comes in. Remember our medical student analogy from earlier?
Yeah, the one where they're like, already a doctor, but now they're specializing.
Exactly. So with transfer learning, you're basically giving the AI a head start. You're not teaching it everything from scratch. You can use a model that's already been trained on this massive data set of general medical knowledge and then fine-tune it with the information that you do have.
Ah, okay, so it's like our med student. They already have a solid foundation in general medicine, but now they're doing their residency in like endocrinology or neurology or something.
Exactly. And what Kumar found was that this approach could be incredibly effective even when the data was limited. He specifically looked at type 2 diabetes and multiple sclerosis, and the results were really promising.
Which is huge because those are both really complex conditions.
Yeah, absolutely. And even with limited data, the AI could still make these really useful predictions. Like, even if a doctor hasn't seen a ton of patients with a particular condition, they can still make informed decisions based on their, overall medical training and expertise.
Right, they have that foundation to work with. So It seems like this transfer learning thing, it could be a real game changer, especially when we're talking about trying to better understand and treat those diseases that are less common.
Absolutely. It has the potential to really shake things up. But you know what? Kumar didn't stop there. He actually went even further and started exploring some even more, I guess you could say, niche techniques to make these models even better.
Okay, I'm listening. Lay it on me. What else did he try?
So one thing he looked into was something called axial decomposition. It sounds a little intimidating, I know.
Axial decomposition, yeah, that's a mouthful.
Right, but it's really not as complicated as it sounds. Think of it this way. If you're trying to make sense of like this massive spreadsheet, it can be really overwhelming even for a really powerful AI. But what if you could break that spreadsheet down into like smaller, more focused tables?
Right, that would make it way more manageable. You could zero in on specific relationships in the data without getting bogged down by all the extra stuff.
Exactly. And that's essentially what axial decomposition does. It lets the AI hone in on certain parts of the data, like the connections between different medical codes or the timing between patient visits, without getting lost in the weeds.
It's like giving the AI a set of tools to kind of dissect and understand the data in a more targeted way.
Exactly. And by processing the information that way, well, the AI can make more accurate predictions, and it can often do it more efficiently, too.
It's amazing how these techniques, they often mirror how we approach these complex problems in our own lives, like breaking things down into smaller chunks to make them more manageable.
Totally. And speaking of drawing inspiration from, well, I guess you could say the real world, Kumar also explored using something called mixers in his models. Have you ever heard of those?
Mixers, like what you'd use to make a cake.
Not exactly, haha. Although I like how your mind works. No, in this context, mixers are actually an alternative to those traditional attention mechanisms that a lot of deep learning models use.
Okay, hold on. Back up for a second. Remind me, what were attention mechanisms again?
Oh, right. So remember how we were talking about multi-headed attention? How the AI learns to focus on the most important parts of the data?
Yeah, I remember.
Okay, so traditional attention mechanisms, they're great, they're really powerful, but they can be kind of computationally expensive. They can slow things down, especially when you're working with these massive data sets like you find in EHRs.
So it's like trying to find a specific book in the library, but instead of using the card catalog, you're flipping through every single page of every single book.
Yeah, exactly. It's going to take forever. But mixers, they're like having a more efficient system. You don't have to get bogged down in all the details, but you can still find what you're looking for quickly and accurately.
So it's like a trade-off. You might lose a little bit of that super detailed information, but you gain a lot in terms of speed and efficiency.
Exactly. And in a lot of cases, especially in healthcare where we're often dealing with these like time-sensitive decisions, well, that increased efficiency can be really valuable.
Yeah, it makes sense. It sounds like Kumar really put in the work to make these models as accurate and efficient as possible.
Yeah.
But it's not just about the tech itself, right? It's about how it's used.
You hit the nail on the head, and that's something that Kumar emphasizes in his research too. We can develop these incredible AI models, but we have to use them responsibly.
Right, because like they say, with great power comes great responsibility.
Mm-hmm.
So what are some of the, I guess, ethical considerations that come into play here, especially as we start to incorporate AI more and more into healthcare?
Tons, right. I mean, like, we're really getting into uncharted territory here.
Uncharted territory with, like, our health data? Yeah, that's a big deal.
For sure. So one of the things that I think is super important is transparency. We got to be able to understand how these models are making their decisions. We don't want AI to be this, like, black box in healthcare, especially when it comes to something as important as our health. Trust and explainability, they're super important.
Yeah, totally. It's like, I'd want to know how my doctor arrived at a diagnosis, right? I wouldn't just take their word for it blindly.
Right. And it's the same with AI. We need to be able to, like, peek under the hood, so to speak, and understand the reasoning behind the recommendations. That way we can be more confident in them and also catch any potential biases or errors.
Speaking of biases, how do we make sure these AI models are actually fair? We wouldn't want them to, like, worsen existing healthcare disparities.
That's such a crucial point. And it really all comes back to the data that's being used to train these models. If that data reflects those historical biases, then the AI might learn to make biased predictions too.
So, like, if a model is primarily trained on data from, let's say, one specific demographic, it might not be as accurate for someone from a different background.
Unfortunately, yeah. That's why it's so important to have that diverse and representative data from the get-go. We got to make sure the data reflects the people these models will be used to help.
And it's not enough to just, like, train the model and then let it run wild.
Yeah.
You need to keep checking in on it.
Right. It's an ongoing process. You have to keep monitoring for bias, make adjustments as needed, and it's not something that data scientists can do on their own. It really requires this, like, team effort, bringing in doctors, ethicists, even patients to get different perspectives and make sure this technology is used responsibly.
It's like building a bridge to the future of healthcare, and that bridge needs to be strong enough to support everyone.
Right. I love that analogy. And actually, speaking of building bridges, one of the things that I thought was really cool about Kumar's research was how he focused on integrating human expertise into these AI models. It's not about replacing doctors or nurses. It's about finding ways to make their jobs easier and more effective.
So it's more about collaboration than competition.
Exactly. There was this one paper where Kumar, he was looking at chest x-rays, and he found that by incorporating annotations from these, like, expert radiologists, the AI actually got even better at spotting those subtle abnormalities that could be a sign of pneumonia or other lung issues.
Wow. So it's like having a second set of super highly trained eyes going over those x-rays, but those eyes belong to an AI that can process images in ways that we can't.
Exactly. And that's when you really start to see the power of this technology, when human expertise and AI come together.
Yeah, it feels like we're on the verge of some really transformative changes in healthcare. It's exciting.
I agree. It's an exciting time to be in this field, that's for sure. And, while there's still a lot of work to be done, I think research like Kumar's shows us just how much potential there is. We can use AI to create this more personalized, proactive, equitable healthcare system for everyone. It's about empowering patients and providers with the information they need to make the best possible decisions.
Well said. Using technology to actually improve lives, that's what it's all about. And on that note, we've reached the end of our deep dive. We've explored the world of EHRs and how AI is being used to unlock their potential to, well, maybe not predict the future, but definitely get us closer. From predicting future health needs to developing new treatments, it's clear that this is just the beginning of what's possible. So be sure to stay tuned because the future of healthcare is unfolding right before our eyes.